Tim, thank you very much for the introduction there, and also I'd like to thank Advanced Hardwood Biofuels Northwest for inviting me. It's a real privilege to come to North America. I haven't been here. Well, I've been here once before, about 5 or 6 years ago. So to come again is great. I just love the place. I love the beer. Portland's fantastic. The beers are great, and I've mentioned about how lovely the beers are. But it has been a real privilege. It has been a real privilege to come here. So thank you all for inviting me, and hopefully now I'll talk to you and you'll find what I'm going to say of interest. It's great to hear everything else going on here as well within North America. I think we've got some great parallels, so hopefully I can bring something else to it. You can hear me okay, because I'll probably wander a bit, but if you start not to hear me, I'll come back to the microphone again. Okay, so I'm just going to talk very quickly about who we are. Who are the Agri-Food and Biosciences Institute? You won't have come across us before. Tim gave a very quick introduction there, but I'll give a little bit more detail. I want to give sort of from an EU perspective and a Northern Ireland more national perspective as well, what the overview and what the objectives are that we're trying to achieve with these kind of technologies, where the drivers are energy and water quality drivers, of course, as well. I want to then talk about the very first proof of concept scheme that we got going with the water utility. So that proof of concept scheme was actually quite important to actually get the water utility to say, okay, right, there's some technologies here outside what we're used to. Let's see if we can investigate them and try them. I want to then talk about licensing and regulation. This was without doubt the hardest part at the start anyway. And I'll go into a little bit more detail about how that has manifested itself. Then I want to go into some of the larger scale schemes. It's all very well getting a small proof of concept scheme going, and compared to the scale of what we saw yesterday, the proof of concept scheme is very small, but you've got to start somewhere then to generate bigger projects. And that's what we've managed to do then with this European funded project, and I'll go into a little bit more detail on that one. Then I want to show how these technologies, using the willow plantations for the recycling of wastewaters, is actually answering some of the questions within our agri-food sector. Our agri-food sector is our biggest sector. We don't have the same industry as other countries would have, so the agri-food sector is very important, but we can't grow our agri-food sector and kill the environment at the same time, so we need to pull these things together. Then I want to talk about landfill leachate applications, and I know there are a lot of brains in this room who have a lot of knowledge on the landfill leachate, but it's an area that we have a huge requirement to deal with, and we need to deal with it soon. These issues are coming up to us. With the willow plantations, I think we've got some of the answers, but we are really only starting to investigate this. And then finally, I wanted to show where we are moving on next with our work. So just ask me, who are we? Well, we're a multidisciplinary institute. We are researching a wide range of interests. We are answering questions for policy. I've run down a few of the government departments there, but really it's the Department of Environment, the Department of Agriculture, even the department that looks after energy as well. We are answering questions for farming. We've got the Farmers Union. We've got agricultural lobby groups, which are looking for answers and research within the agriculture sector. We work with an advisory sister organization called CAPRI. I think it's similar to what you guys call Extension. So the College of Agriculture, where they are actually going out onto the ground and making these initiatives happen from our research. Then we're working also for industry, the bioenergy, the agri-food, the energy industries, the water utilities, and then, of course, the Ireland and other UK organisations. We span a whole range of disciplines, as I mentioned, so we are very much going to focus, or at least I very much focus here, crops, grassland and ecology, energy crops, the use of energy crops, wastewater recycling, but we span all the way through grassland-based agriculture, of course, for our dairy and our beef industry are our big exports, but we also look after work on fisheries and aquatics, food science. Anyway, it's a massive, great big range, but that's just to give you a picture of who we actually are. Within my own section, Tim explained it very well there in his introduction. It is indeed, it's all the way from field all the way through to furnace, and our activities get involved in the whole value chain, trying to develop this value chain. Can we introduce sustainability and energy into the agricultural sector was the original the original reasons, but certainly now we're trying to push further on. It's not just bioremediation of farm wastewaters, but also municipal wastewaters and wastewaters, as I mentioned, from leachate as well. But some of the work that's done before, which my colleague, Professor McCracken, would have worked in, which would have been improving disease resistance, we have, although we've taken an awful lot of the work and the examples that the Swedes have done for us before, we have different disease pressures. And one of the main issues we had to try to fathom at the start was, can we actually plant these large plantations of willow crops
and not suffer complete wipeout through disease. So there's a lot of work done on this a good while ago, 10, 20 years ago, and this has now resulted in successful plantations that are growing, which are resistant to disease because of multi-clonal planting. Okay, so I always like this one this slide because it just brings these things together. We call these trilemmas. Within the EU, we have this energy trilemma where we're trying to increase, it's the same around the world, we're trying to increase the energy security, decarbonize our energy, and improve the cost. I mention this because fuel poverty in our own part of Europe is massive. We have over 40% fuel poverty. So it is something we really need to try to deal with. And it's difficult when you're talking about expensive renewables and very cheap fossil fuels. You know, how can we actually force a decarbonization at the same time as improving fuel poverty? It's a real difficult, contradictory trilemma. And then, of course, on the other side, we've got our water utilities, which are being pushed further and further down the route of trying to do a similar kind of thing. Reduce the carbon, reduce the cost, reduce improve the compliance and of their discharges, and all the same time reducing the cost, improving profitability. So this is something which they kind of think, that's contradictory as well. But point is, can we bring these things together? And energy targets, water framework directive targets, which I'll talk about secondly, we can bring these things together and we have holistic solutions. So yes, there are definitely avenues and there are potentials where we can use energy crops to deal with both of these different types of these contradictory trilemmas, but give solutions that are real solutions and can increase agricultural diversity and indeed economic opportunities within Northern Ireland, which don't currently exist. So energy targets. We do have these energy targets. We have a legally binding Greenhouse Gas Reduction Climate Change Act where we have to, in the UK, 34% reduction in greenhouse gases. We have this directly translated into our own legal framework. But importantly, and I think what we do have is we have these heat targets. We have to, by 2020, within Northern Ireland, produce 10% of our heat from renewable sources. 10% of that must come. Now, we started off at 1.7%, and we are finishing up around about now at 6%. Well, no, don't say finishing up, it's sort of 4 years to go. So around about 6%. So 6% of all our heat is from renewable sources. Now, it started off at 1.7 about 3 years ago, so that's a fairly good and fairly successful increase. And that was all on the basis of incentivization, biomass incentivization. You probably see it in the news, but the EU is, well, certainly the UK is pushing that quite strongly. It's not cheap, though. It's certainly an incentive that is costly, but it's achieving it in the right way. We have the similar thing for electricity as well, of course. We have to try to achieve 40% of our electricity from renewable sources. It's worth mentioning just on the heat target that although it is encouraging all kinds of heat technologies, heat pumps and what have you, 98% of all the renewable heat is from biomass. So that is the value chain that we're feeding into. That is actually what we have, and I think we're quite lucky for that. Just to mention as well, in the UK government, there is a 15% renewable energy directive, to 15%, and of course there is a commitment that 11% of this will come from, just to go back, that 11% of this will come from primary and will come from biomass. So we're not going to completely dismiss biomass and concentrate solely on wind turbines. I mean, the majority of the electricity that is produced from non-fossil fuel sources is indeed wind turbines. So that is the energy policy. However, with oil sitting at the price it's at, it's not the biggest driver for renewables, for biomass production. So we have to look elsewhere. And this is where we are really concentrating and where I'm going to really talk more about in this talk, and indeed what we're talking about in this meeting. So we've got the EU Water Framework Directive, which is probably similar to your, I've heard some of you mention it, the clean water, whatever it is, yeah, there's something, so probably along that line. So we have to try to improve the quality of our water, and we're way behind for the same reasons as you guys are. In Northern Ireland, we have this consultation that was released a couple of years ago, and it's called the Department of Regional Development Long-Term Water Strategy. So mainly, this is the government department telling the water utility, this is where we should be heading. And within this consultation document, it does recommend we introduce sustainable technologies. You know, we look at technologies outside the box that we're currently thinking on. We look at regulation and see if regulation can work compliantly with other solutions. And hopefully, by the end of this talk, you'll see that actually this is starting to happen. We've also got this, I mentioned before, this Agri-Food strategy growth. Okay, so the Going for Growth document here is all about increasing food production. I mentioned that agriculture is our biggest sector. This is really where our revenue comes from. So when you have a successful sector like this, you try to develop it, you try to grow it, you try to make the best out of it. This is what we have to supply. So Within this, we are looking to increase our food production by about 60%. And increase agri-food processing as well. But of course, with an increasing agri-sector, we are going to have increasing outputs, we're going to have increasing energy demands, we're going to have increasing waste, we're going to have increasing wastewater, increasing potential for pollution. So we need to keep an eye on that. And it's worth mentioning that within this strategy, this industry strategy, there are a couple of recommendations. And one of these recommendations, government must develop strategic land management policies specific to agriculture, whilst enhancing environmental sustainability. So it's kind of saying, great, increase agriculture, but make sure that you work the land with it at the same time. Now, I think this is an absolute opportunity for us to introduce energy crops to work hand in hand with a developing agri-food sector. And hopefully I'll illustrate that in some of the small schemes that are being developed. Also, another recommendation, government must review incentives for renewables to be complementary to the agri-food. Okay, so this was, in my mind, very much written at the start because the food-fuel debate has always been, balancing one side and the other. And we have developed a fairly robust anaerobic digestion sector. It's not so much the biomass. So this is really aimed at the anaerobic digestion sector. So much grassland going into AD plants rather than into cattle and into dairy feed. So it's keeping an eye on this. But I think we'll understand, or at least hopefully by the end of this talk, that there are definitely ways that we can illustrate the complementarity of growing biomass energy crops, willow plantations, along with agriculture, and the whole thing can work very much hand in hand. Water Framework Directive, there's a bit too much writing in this slide, but really it's just to illustrate the fact that we do have to aim for this. 72% of our rivers have phosphorus levels above what could be eutrophic. Okay, so that's not a great result. 6 lakes eutrophic, 11 mesotrophic. And the point is that the removal and reduction of small point sources can help us try to improve these, and that's where we're moving. Okay, so I wanted to mention now, as a background, some of the activities that we're actually doing, the more interesting stuff, the on-the-ground activities. Proof of concept scheme, I mentioned, it took a while to get here, but the water utility willingly embraced in an engagement with the private sector and with the research organizations as well, and we have the small scheme that's up and running. These are the reasons to do it, and we've come across these reasons yesterday as well, but it was also within the recommendations of the consultation document. So we took a small wastewater treatment works. Compared to yesterday's, okay, tiny, but we have to start somewhere. So small conurbation, but 23 people. They were discharging into a small stream, from the wastewater was discharging into a small stream. And this is the treatment works that was there. So hopefully you can see that picture quite clearly. It's simple. You've got the wastewater comes down into a battle retention tank, makes its way through the retention tank into a gravel filter, soaks through the gravel filter, and it's just discharged. And so what we did then was adapted the discharge down here in the bottom right. You can see adapted the discharge down there, a couple of different pumps in, and then what we do is we pump that effluent out in a controlled methodology out into the willow plantation. Boreholes within the plantation, you've got a general sort of flow of groundwater this direction here. We analyze the water upstream, analyze the water downstream, analyze the water in all the boreholes, and this has been running now for a couple of years. All the data from this, data collection to try to prove to the Environment Agency, to try to prove to the water utility that, look, these are technologies, these are solutions that can actually work. So the data acquisition is important. So all the schemes we put in, of course, are the high-tech SCADA, where we can log just about everything. And yeah, we do, where we're finding that through the irrigation history of this, and we spend too long on that, but through the irrigation history, we are irrigating fairly regularly the inflow to the outflow. Yes, there's breaks and controls. We have environmental controls. When it's raining, we stop irrigating. When the temperature's too cold, we stop irrigating. It's all written into the regulations. But really what we're doing is we're proving that technology actually does work. We're not getting any breakdown in the site. We're not getting any deterioration in the boreholes. We're irrigating about 2,000 cubic meters per hectare per year. Total nitrogen, 90 kilos. Now I'm talking kilos per hectare, which I've been trying to sort of do these sums and work back from pounds to acres, but I'll probably have to do a little bit more mathematical crunching on that. But these are the rates that we're getting here, about 90 kilos of nitrogen, about 12 kilos of phosphorus per hectare per year. Now they're well within the nutrient offtakes with the crop from our own research. So it's proving to be sustainable. And we are showing that we are recycling about 90% of the inflow into that treatment works out into the willow plantation. So about 10% of that is being discharged back into the stream. So we're getting a good result from this. So just want to talk here about licensing and the regulation. First, I can remember the first time going into the regulators, and really what much, it was a kind of a, you want to do what? You want to irrigate wastewater into an energy crop plantation, and there'd been no precedent of this in Northern Ireland, so it was a real kind of learning curve was required to develop this, even though there were many precedents, and we'd taken most of our technologies from the Swedes, who've been doing this for a long time. We had to develop it from scratch. So we have the regulatory instruments. We have the water discharge certificate within Northern Ireland, which is allows us to discharge point sources into the receiving waters. And that was the tool which they adapted at the time into dealing with wastewater into willow plantations. However, of course, this is all on a discharge point. Now, where is the discharge point if you're discharging into a willow plantation? There is no discharge point other than at the application. So you're applying the wastewater at the head of the treatment system, which is the soil plant system. So where's the discharge point? You could say the discharge point's maybe at the bottom of the rhizosphere where you're hitting groundwater. So this was a real kind of hurdle we had to get through. And as such, it was very heavily regulated at the start, and we have to then try to develop confidence, which is what we're in the process of doing. In the south, because I am talking about the two jurisdictions here, in the north and the south, it's a very similar process, but it's under a planning authority, it's under a planning approval. But really what we're doing here is in order to get the permission, in order to get the proofs and the regulatory certificates to discharge into an energy plantation, we are having to run through public notifications. We need to analyze and assess discharge points, sampling points. There's continual environmental monitoring. Of course, the nutrient management planning is massively important. Irrigation and discharge conditions, these are all built into our nitrate directive, which comes out of our water framework directive, so we comply with all these things as well. And temperature, rainfall, proximity to watercourse, cover all those, environmentally control them, and we've got a working solution. So this is really where we are. But I just want to mention this last bit here. Variable discharge consenting is what it's called. And this was in my mind, a great leap of faith for the Environments Agency, because it makes the whole use of these technologies actually plausible. The issue we had was we can discharge to a willow plantation, that's absolutely fine, but the way the regulations were is you either discharge all of it to the willow plantation or none of it. So you can't do half and half, which didn't make any sense, because there's certain times where we get some quite serious rain. It probably comes as a shock, but we get some very serious rain, and we cannot discharge to land when we're getting that serious rain. But at that particular time, the regulations were stating that we must store the wastewater during the heavy rain times and then discharge that back onto the willows when the rain stopped and the land had dried out. And to me, that made no sense, because the river was flooding past you and you had massive dilution. And of course, the whole trip yesterday out to Woodburn was all about the dilution potential of the river as to whether you're going to discharge into the poplars or not. So, it was a no-brainer. Anyway, the regulation worked very well with us. So this came out, which actually is variable discharge consenting, which allowed a back-to-back discharge certificate to work. So we can apply to the land when the land can take it, but when the land can't take it, we can apply it back into the stream, which makes great sense. So we get rid of all that carbon footprint of tanks and concrete and storage and all that sort of stuff, and we just use the land when we can use it and then use the stream when we can use it. And that's the basis on which these technologies are moving forward. There's a bit more complexity to it because the EU regulations are quite tight once the treatment systems get bigger and bigger, but I think there's scope to work in this direction. So I mentioned nutrient management. Yeah, it's all about how much nutrient we can actually apply, whether the sustainability of the scheme operates or not. And this research has come from research on our own. My colleagues within AFBI have worked on this, but also our colleagues south of the border in the Republic of Ireland have worked on this as well. There is a fertilizer manual, which you might be aware of, and this gives the farmer an indication, a guideline of how much nutrient he should be applying to his crop. But it's basically on economics. And it's worth mentioning that within this recommendation, the last publication of this document that was written, there is an inclusion for the very first time, energy crops. And within the inclusion of energy crops is the understanding and the appreciation that when you are applying wastewaters to an energy crop, it's not just for fertilization of the crop, it's actually for a biofiltration function. And this was a huge victory at the time, because it actually now says, right, it is a crop that it's not just grown for energy, it's grown for waste management. And that was a big win. But the schemes we have running, if anybody's of interest in that, it's between 24 to 70 kilos of nitrogen, 3 to 8 kilos of phosphorus, and the hydraulic loading is about 1,300 to 2,200 cubic meters. That seems to be operating. That's what we're finding the schemes very happily and sustainably running at. And these nutrient application rates are well within the nutrient guidelines that are given. So what are the next steps? We have to take this technology and move it on. It's all very well having one small concept, proof of concept scheme for the water utility. It's all very well working with the environment agencies. We need to get these schemes out there. We need to get them to actually do something of more use. So we need to bridge this valley of death, what we call it, get it from the lab bench out into the environment and used. We need to inspire further regulatory confidence, further commercial confidence. It's fine if the regulatory confidence there, but if there's no commercial interest or trust in the technologies, we're not going anywhere. And we need to publicize it. So we need to get these larger term trials. So as such, we embarked on an EU funded project about 5 years ago. 5 years ago, it ended in 2014. And this was a cross-border. It incorporated several different partners, research institutes, north and south, and also some of the local authorities, and up north, the water utility, Northern Ireland Water. It was a $3 million project over, there's me translating currencies there, hopefully I got it right, over 4 years. And really what we were doing is we wanted to look at the different genotypes and wanted to look at the upscaling of these technologies. We wanted to have a look at, to a small degree anyway, the sort of the human pathogens and the biodiversity and the earthworms. But really what we wanted to achieve out of this was real functioning, larger scale schemes. Okay, not larger scale than compared to what we saw yesterday, but for willow schemes and our own conurbations that we have, these are functional scales. These are scales that are really answering questions, bringing wastewater treatment works into compliance. So we developed 4 schemes out of this, and then we did some initial platform constructions for some leachate work. And I'm going to concentrate just on one of them here. It's a 14-hectare site. Now, this 14-hectare site is it's dealing with a population of about 650, 700 people, which is the whole conurbation. The different treatment works that took some upgrading. This was a wastewater in, an aeration vat. The aeration stops. The supernatant then floods out into the stream, and that's the way that one would work. Upgraded. These are peat filters. These are typical ways that we manage our wastewaters. RBCs. So those are the kind of schemes. What we did here, we construct pipes, mainline pipes, automatic valves. You can see on the right-hand side, we've got 4 big pipes heading way off into the willow plantation, all buried. Each one of those pipes is controlled by a different valve. So when the valve comes on, it'll then pressurize one of those pipes. Then one of those pipes then will irrigate in a particular direction. Sometimes the mainline pipes are actually buried if we're crossing roads or up through forests. It's not always easy, of course. Some of the land is really, really quite wet. It takes some kind of drainage, but I think that sort of shows that we do indeed have difficulties. And then ultimately, we can see here in a small plantation, it's just 1-year-old whips here growing, but we can see the pipes running up through the willow plantation, and that blue pipe that you see there is one of those blue pipes that we saw earlier. That'll be buried, which then allows us complete access to the crop. We can harvest it as and when we require. I just quite like these pictures because it shows us very clearly how the pipes are laid out in the willow plantation. So unlike yesterday's visit, we tend to use these ground-mounted pipes. The pipes are laid and they're never lifted again. Each yellow cap shows you an irrigation point, and the effluent then comes out of those yellow caps. It's pressurized. It's pressurized, but there is no extra control on the outflow. So they're just holes that are vary in size through the direction. So there's no real upkeep required in these pipes. To date, anyway, there's no real upkeep. So along comes the harvester, takes the biomass away, leaves the pipes in position. I think this is quite a neat way to do it. And I have to say, I like this picture because not only was it a sunny day, but we can see the irrigation is just starting to happen again. So we see small time irrigation out on points with good eyesight. You can definitely see that one, I think, but you can see some irrigation up here. And we'll see a few lines away. We'll do the same thing in another row as well. So that's how the irrigation happens. Just to show where that plantation sits, I thought this was quite a useful photograph. I headed up onto the hill and took a photograph down. I mean, these are the fields that we're irrigating, and it's in quite a beautiful part of the country, and really nobody knows it's happening. Although, of course, there was all the consultation. It's a very discrete solution. Just to zoom in a little bit more now, these are the few fields. The tractor sank in this one here. It's a field that never really had any particular use before, so it's great to bring that field now back into some commercial use for one. 3 fields, about 14 hectares. These 3 fields then were upkept and brought into production. The irrigation pipe, there's the irrigation pipe from the treatment works all the way down to those pipes. Discharge point is always here in the river, but of course now we're discharging to the river. So what happens, we've got PLC control, we've got environmental stimuli, which are temperature, air, soil, and of course rainfall as well. The rainfall will react according to the amount of rainfall and the intensity of the rainfall to turn the irrigation system on and off according to how we set it. And the valves then will turn on and off. Each time a valve turns on according to the preset programming and the environmental stimuli, that particular area of Willow then will be irrigated, as the demonstration is showing here. So little and often, this particular irrigation system comes on 3 times a day, irrigates each zone for about 3 or 4 minutes, 5 minutes, and then goes back. So by this, we are not causing any flooding, we're not causing any runoff, we're not causing any pooling, and it seems to be a sustainable work so far. What kind of results we're getting from it, I think, is interesting. This has been running, as I say now, this is the first year and the second year. I wanted to start it to give you almost 2 years of data. But the inflow, 65,000 cubic meters, we're irrigating about 30,000. Okay, so recycling only 47% of the inflow, but all year round. I think if we examine it though, if we look at the summer months, June, July, August, September, 85% of all the inflow is being irrigated. So only 15% of what used to head out into the environment is actually heading out into the environment. And I like that result. And the same then when we hit the other dry months, April, May, when I say dry months, the drier months. During the big wet months, we can see there's an awful lot of inflow, and we obviously can't keep up with that. There's many days we can't even irrigate. But those are good results. Then in this year as well, we can see we've got a similar pattern, but if again, June, July, August, September, we've got 81% of all the inflow has been recycled. And again, 75 kilos of nitrogen, 4 kilos of phosphorus is the approximate application of nutrient that we're giving this plantation. Agri-food sector. Just very quickly, what's happening is with our agri-food sector, with intensification and with the growth of the agri-food sector, what's coming into mind is, okay, what am I going to do about my wastewaters? I don't want to get prosecuted. I'm going to have to do something with it. What can I do? Do I need to bring in a wastewater treatment facility? If so, I've got to then tanker my wastewater elsewhere. So these thoughts are going through the producer's head. And what really comes out at the end is, well, what about I just treat it on site in the minimal way I need to treat it on site and then irrigate it on site? And that's really where these solutions have reached some conclusions. I'm going to show you one here. It's been running for about 8 years. It's a dairy sector. It's taking wastewater from cleaning out all the milk vessels before the bottling. It's exactly the same as the scheme I showed earlier, and this is irrigating about 26,000 cubic meters of wastewater a year. Okay, it's analyzed again. We check the water, we check the borehole water. So 26,000. This is previously what was happening is this wastewater was being driven to a wastewater treatment works. Time after time after time, tractor and tanker, tractor and tanker. Now this is just pumped and recycled in a really sustainable manner. We've got the same thing here with the fruit processor, doing exactly the same thing, pre-processing it, filtering it, neutralizing it, and irrigating it. And he's irrigating it at 44 kilos of nitrogen, 5 kilos of phosphorus. What's nice about this guy, though, is he's not just growing 4.5 hectares of willow and recycling his wastewater locally, but he's installed a 99 kilowatt boiler, and he's actually using that biomass now to create the heat for his processing requirements that he needs in the factory. So he's winning environmental prizes left, right, and center. But he's done this off his own bat, talking to guys like ourselves. He's done it off his own bat. I think it's something that we could push more, and we can get more of these solutions to run. So look, there's a few of these. There's a fruit processor. That's the one I just showed you there. There's another fruit processor. Farmyard dirty water runoffs. A couple of those. There's an abattoir, actually, where he's irrigating it, not the blood and everything, but where it's held. Another couple of schemes. This is one in Northern Ireland as well, which is a 2,500 population village. And what we're doing here is we are going to be taking a chunk of the flow when the peak flows are happening or whenever the river is low flow. So it's very much similar to yesterday's scheme. Take that excess flow and irrigate that up into a plantation. So I've only got a couple of minutes left, Tim tells me. So I just want to very quickly then outline where we're going with the leachate. The leachate issues are a serious concern, and we're only just starting now to look at how we deal with these. Estimates show that we probably tanker around every year about 1 million cubic meters of leachate, and it's costing us 13 million to tanker all this. And these figures are fairly recent. The Environments Agency has some staggering challenges to face up to, essentially from closed legacy and also illegal landfill sites. So how can we do this? Well, We do have a scheme, and I just want to concentrate on it slightly. There is a landfill site that has been closed for a number of times, and the site has been restored. This site has got football pitches and walks and bird sanctuaries and ponds and you name it, but it's also got a 4.5-hectare plantation of willow, which has been designed, and that willow is due to be planted this year. But as things stand, we don't know if we can do anything with it. It's nice to grow it, but we don't know if we can do anything with it. There are a lot of regulatory questions. How can we irrigate this leachate? We haven't done it before. We don't know what the efficacy is like, how good it's going to be. Just to show where it is, however, up here on the right-hand side, we can see there's the landfill site that comes in. We've got 4.5 hectares of willow there. We've got a biomass processing centre down here, which can process the wood chip, dry it, and screen it. We've got a school here, 99 kilowatt, that's actually using the wood chip. I think it's the most obvious piece of circular economy. The EU loves this circular economy thing, and we have a real good demonstration of circular economy here. But we just can't irrigate it yet, because the main question is, if we irrigate the leachate onto that willow, will the willow actually work in managing that leachate? And when the rain comes down, is that rain now not de facto leachate? And why would I deal with a 12,000 cubic meter a year leachate problem if I'm going to then have 40,000 cubic meters of rain, which is now leachate as a result? So I need to kind of manage that. So has come out of this ANSWER project, we have a research platform here, which is just about to run. I've just got funding for it, where we're going to analyze different rates of leachate irrigation into willow plantations in triplicate, so we can see it work. And here is a scheme that has been running now for, it's just about to be commissioned. We were lucky to get it built. It's a 3.5 hectare willow plantation in conjunction with integrated constructed wetlands. This gives us the belt and braces where we can actually now irrigate the leachate in a proof of concept scheme onto a willow plantation. Any leachate or rainfall that runs off will run off into this gully in the middle, and we can then analyze that. I've just got a quick summary. Okay, so the leachate is irrigated on, the rainfall falls on top of this. Once the rainfall comes down here, we've got some continuous analyzers, digital analyzers for COD, analyzers for ammonia in particular. Depending on the concentration of that leachate or of that drainage water, we can either discharge it or recycle it back to the head of the works. So this will start to answer these questions: is can we actually now irrigate the leachate onto this scheme and let it work? And the Environments Agency are waiting for the data from this so they can let that other scheme operate, the real functional scheme. So I think we've got some good potentials. It's not easy to plant a willow plantation on a landfill. You know, all that imported topsoil. It's a killer, and then you suddenly get a drought. You know, you wait for a summer for 20 years, and then suddenly you get one when you don't need one. So you can see the willows starting to come up here, and then we finally get them. So it was tricky. The future work, 'cause I know I'm finishing up here, Tim, just a minute, but the future work where we're trying to move on to now is really we want to determine the extent of wastewater. We mentioned the Water Framework Directive. We want to test the extent of point source discharges and the effect they have on wastewater or Water Framework Directive monitoring points. So can we actually prove the linkage on these? And then, of course, we've been talking about diffuse pollution mitigation, and we want to bring these in as well, all based on the biomass supply chain. So can we develop this? And all I'm wanting to say here is there is certain amount of research that show that depending on the wastewater treatment work and its proximity to a Water Framework Directive reporting point, we can show that there's a linkage. Now, if we can actually deal with some of these wastewater treatment works using willow plantations and have an effect on these WFD status, we might actually find an uptake of these technologies in a much bigger degree, which is where we're trying to get to. And then from a diffuse point of view of using plantation to actually manage wastewaters in the landscape that we have, we are also looking to investigate whether these riparian strips can indeed, as we all know, whether they can indeed intercept flows, break the flow of water, increase percolation, increase sedimentation, and prevent all this phosphorus running into our waterways. So this is the next step that we're actually trying to get to. And this has been a subject of a recently approved project. So we now do have some money to prove that these technologies work, because this is coming forward on the land strategies. Okay, so just some conclusions there, and really all I'm trying to say in that conclusion is the use of energy crops to manage these wastewaters are answering so many questions. It's not just siloed, it's answering so many questions. It's agricultural diversification, it's environmental improvement, it's energy, answers for energy, it's infrastructure, affordable infrastructure. So I think we do have some technologies which we can certainly make an awful lot out of. And this is something I just literally found out about not long before I came out here, and you guys are probably aware of it, but there are US-Ireland linkages which are tripartite funded, the US, Republic of Ireland, and Northern Ireland. And although none of these particular areas are what we are studying at the moment, I'm told to keep an eye on it because they could sort of come up in the future, and that could be quite exciting if the opportunities ever existed to start to join together in some of this research work. So that's me. I know I ran a minute or two over time, Tim. I'm sorry for that, but thank you very much for listening to me. Thank you.